Alright, I went ahead, this is 4.1 part 2 video. I went ahead and did example 1, and I'm going to talk it through with you guys, and then we'll do the rest together. You can always pause and then speed it up and check your answers at the end, but make sure you're doing these first, practicing, and just make sure you're getting it correct before you move on to the homework. So letter A, we have the function f of x equals 7x squared minus 4x cubed minus 2. So what I did is I pointed arrows towards each exponent, identify the numbers of the exponent, and then I also put a number under the constant. I always know the constant's going to be my very end, and then I look for my highest degree as my first. So I have negative 4x cubed because cubed is larger than 2, so then I put that first, and I put the entirety with the sign as well. So don't forget that negative is attached to that 4x cubed, and then plus 7x squared minus 2. Because it's 3 to the power of 3, that's a cubic, and it's 3 terms, so it's a trinomial from the number of terms with our name. And then our leading coefficient is in front of our highest degree, and that being a negative 4. Okay, so this next one. This one's a little bit different, so I'm going to box in the exponents. If I look at both of these exponents, notice one of them is a variable. That should automatically tell you that this is not going to be a name of a polynomial. It's not a polynomial because n cannot be an exponent. So anytime you have a variable in your exponent, you can't, because if you went to solve for that variable, a number higher than the value of n to the power of 2 could possibly be that value of n, so it can't be a polynomial. Hopping to letter C. So same thing from our chart in our properties of polynomials. I'm going to look directly at my denominator here. I have x squared plus x cubed plus 1. We can't have x in the denominator. That is not a rationalized function. So x cannot be in denominator. So this is not a function or a polynomial. Sorry, guys. All right, letter D. We have q of x equals negative x cubed minus 4x to the power of negative 4, and then minus 3x. So I'm looking at all my exponents. I have 3, I have negative 4, and we know that x, a single value of x, has a imaginary, in quotations, value of 1 in the exponent. So looking at my exponents, I should automatically be drawn to the negative 4. And in my properties of polynomials, I cannot have a negative exponent. So x cannot be negative. Or it can't have a negative exponent is what I should say. So x cannot have negative exponent. Okay. 2 more. Letter E. R of t equals 19 plus 0.5 t squared plus the square root of 3 t to the power of 4. So I'm going to box in my exponents. This is my constant, so I'm going to underline it, my 2 and my 4. The important part to look at for this equation right now is that the exponent is on the outside. So t to the power of 4 is outside the radical, it's not inside. So this is actually a polynomial. So let's rewrite it in its standard form. So r of t, the 4 is larger than the 2, so it goes first. So we have the square root of 3t to the power of 4 plus 0.5 t squared, and then finally with our constant value of 19. Next is to name it. So we have an exponent of 4, and so if we look at our chart, we know that's going to be the number of the term with a polynomial. So the number of term is 4, which is quartic. So it's going to be a quartic polynomial. Okay. And leading coefficient in front of that highest exponent, this time it is a square root of 3. Okay, last one. S of x equals the square root of 3x. Okay, this is where I know it's not a polynomial because it's under the radical. Remember, anything that has a square root of x, it can also be written as x to the power of 1/2, and we can't have that, okay? That's too small. So that means that this is not polynomial because x cannot be under a radical. Okay. All right, now we're going to evaluate a function at a value. So we have a quartic function, polynomial function. We've got 4, 3, and then 1 and 11. And they're asking us when n equals 4. So we know how to function substitute. So we have f of 4 equals -2n, which I didn't even plug it in. Erase that. Do as I say, not as I do, you know. -2 to the power of 4 plus 6 times 4 to the power of 3 minus 3 times 4 plus 11. Okay, use your graphing calculator as an exponent. You do get to use your graphing calculator for this section, so please utilize it to its fullest. And so because I'm filming from my Notability, I can't show you the calculator, so just do with that what you will. So pause it, plug it into your calculator, and then once you plug it in, you should get -129 at the evaluating function at f of 4. Okay? Alright, first page of notes completely done. Okay, let's move on to the second page of notes. Alright, so for a polynomial, the end behavior of the graph is determined by the function's degree and the leading coefficient. So what we're going to be doing is sketching graphs based on their end behavior, depending on if they have an even, odd degree and their leading coefficient. So this table is going to be a great reference sheet for y'all. You do need to be able to memorize these, okay? So when you visually see something, you're going to need to know the end behavior. So flashcards are super helpful, and something to put on your flip chart would be awesome as well. So positive leading coefficient with an odd degree, you're going to have x heading towards infinity. So on your x-axis, x is heading towards infinity, and y is also heading towards infinity. And let me make my pen a little bit smaller to make my infinity symbols. Okay. As x is leading to negative infinity on the x-axis, y is heading to negative infinity. And I'm going to sketch that for you. So as x is going to negative infinity, y is going to negative infinity. As x is going to infinity, y is going to infinity. Continuing on with an odd degree. If I have an odd degree but a negative leading coefficient, as x goes to infinity, y is actually going to negative infinity this time. Sorry, my infinities aren't very good with writing on the iPad. And then my arrow goes this way as x goes to negative infinity. And then as x goes to negative infinity, y goes to infinity. Which I wrote that first, but they're both on there now. Alright, even degree, positive leading coefficient. All the values head towards positive infinity for y. So as x goes to infinity, y goes to infinity. And then as x goes to negative infinity, y goes to infinity. Alright, final even degree, negative leading coefficient. We actually have the opposite of even degree, positive. They all are both going towards negative infinity. So as x goes to infinity, y goes to negative infinity. And as x goes to negative infinity, y also goes to negative infinity. So looking at example 3, let's apply what we just learned in our table. And again, you're learning this for the first time, so it's going to take a second, but it's good to apply the table from directly looking at it, and it helps you memorize it. So example 3, given the graph of an unknown polynomial, determine the sign of the leading coefficient and state whether the function has an even or odd degree, okay? I'm looking, my arrows are both pointed this way. This is the end of my degrees, okay? Looking at my table, okay, both as x goes to infinity and negative infinity, we can see that both arrows are pointing down towards negative infinity on the y-axis. So if I look at my table, that means I have an even degree. Okay, I'm going to zoom in a little bit more to write a little bit better. And then if I'm talking about my leading coefficient, both go down. I'm looking at my table, and so leading coefficient is going to be a negative number, so I'm just going to show it as less than 0. Not equal to, but less, because it has to be a negative value. Letter B. I have an arrow. As x goes to negative infinity, y is going to negative infinity. As x goes to infinity, y is going to infinity. So if I go look at my table, that's going to tell me with my arrows going in opposite directions in the third quadrant and first quadrant that I'm going to have an odd degree. And I'm going to have a leading coefficient that is greater than 0. And my thing just erased itself. Okay. All right, pause the video, do C and D like we normally do in class, and come back together. Okay, hopefully you're coming back from pausing. If not, make sure you are actually applying yourself for the homework. Okay, so C, I have an arrow going towards infinity on my y when x goes to negative, and as x goes to positive infinity, y is going to negative. So this also means I'm going to have an odd degree. And then I'm taking a look at my odd degree with my arrows going in opposite directions, and my leading coefficient is going to be less than 0. Because they're going in opposite quadrants. This time it's the second quadrant and the fourth quadrant. That's why the leading coefficient is less than 0, not greater than like B was. Last but not least, D, as x goes to negative infinity, y goes to infinity. As x goes to infinity, y also goes to infinity. So this is my very nice even degree, while the leading coefficient is going to be greater than 0. Okay? All right, let's move on. Oh, my E disappeared on my word even. Okay. Now, instead of identifying the degree in the leading coefficient, let's talk about in behaviors if you're given a function. So the first thing, and really the only thing you're going to look at, is the highest degree, because that determines it, and if the number is going to be even or odd, right? Positive or negative, leading coefficient. So, looking here at my first example A, f of x, I'm looking only right here, because that's my highest degree. The degree is going to be 3, and so that's an odd number, and it's negative. So I'm going to have an arrow going up in this quadrant, and then an arrow going down. And then I can sketch the function like so. Okay? Alright. Letter B. Okay, looking at my highest degree, let's box it in, because unfortunately this function, we should know, is not in the standard form. My degree is even, and then I have the number 4, which is positive. So that means both my arrows are pointing upwards in the first and second quadrant, again, from my table. I'm not just getting this information out of thin air, okay? You've got to memorize the information from the table based off your odd or even and your negative or positive. And then we can sketch the graph based off your graphing calculator. Okay? Not going to be perfect, right? We're just trying to figure out the end behaviors. So don't stress out about making the graph perfect. Alright, try C and D like I said before. Take a pause. Okay, hopefully you paused. And then we have h of n equals negative 4n squared plus 2n cubed minus n. Again, not in our standard form, but we're going to box in our highest degree. This is an odd degree, and it's a positive number. So we're going to have our values going in opposite directions. One's going to be in the third quadrant. One's going to be in the first. And then we'll sketch our function like so. Okay? Then this next one, D, we have negative 3x to the power 4. Looking here, we have a even degree, but we have a negative positive, or not negative positive, counterintuitive, a negative value of our leading coefficient. So both my arrows with an even degree but a negative leading coefficient are down. It's going to be my third quadrant and my fourth quadrant of my graph. And then I can sketch the rough sketch of my graph like so. Okay, because zooming in and out is not going to really help you, because sometimes it's going to be too big on your graphing calculator, so it is important to know your own behavior. Okay, I'm going to pause this video here because, again, it takes too long to upload, and so it's a nice small size minute so you can break apart your lesson, go grab a snack or whatever you need, and then we're going to finish the lesson with example 5, 6, and 7. Oh my gosh, typo, guys. I'm realizing that this should be a 7. Okay, so take a second, come back, and let's finish these last 3.